A compound inequality is when you have a situation where the answers for X have to either meet two conditions or one or the other. To help you understand this a little bit better, well, first let me highlight that top piece, and then I'm going to have you possibly stand to answer a question. So compound inequalities, this is our focus today. It's a pair of inequalities joined by an and or an or. To help illustrate this principle, what I'd like you to do, I'd like you to stand if you are a girl and you have hair. Stand if you are a girl and you have hair. A girl and you have hair. Okay, well done. Now, stand if you are a girl or you have hair. Stand if you are a girl or you have hair. Or you have hair. Well done, guys. All right, everybody's standing. If you were in a group of like 30 to 40-year-old men, you probably would, there'd be a lot not standing. But you guys understood the idea. It's either an and situation, meaning only the girls stood because they are only girls and have hair. An or situation has a lot more answers involved, a lot more people that could fit the bill. Okay, thank you guys for standing. If you could take a seat. This is going to be our area of focus today. You're going to be solving two inequalities, and you have to list the solutions that either make both true or make one or the other true. So let's go ahead and let's start with the first situation, the and. Compound inequalities involving and finds all the values that make both inequalities true. Another thing to be aware of, this could be written as one inequality, like this. This would read X is greater than -4 and less than or equal to 2. Or you could actually just separate it into two inequalities. And you have the same thing written there, it's just separated into two. They both mean the same thing. So let's go ahead and see if we can solve this in example 1. Graph the solution of the compound inequality given below. Express your answer in interval notation. So since we have two, we're going to solve for both of them separately and then assess our solutions. So looking at the first one, what would you guys do here? Good, subtract the 2x. And we would get -1 is less than or equal to x. And I have to solve for the other one. So what would you guys do with this one on the right? What would you do first? Would you add the 9? You could. Most of us probably would combine like terms first, so subtract the 4x. But you could add the 9 and then subtract the x. And that would give us -3x is greater than -9. I purposely want to do it this way so that I can remind us of something. Now to get x by itself, I need to divide both sides by -3. And guys, what do you have to do when you divide by a negative in an equality? Flip the sign, nice Jay. So this has to be x is less than 3. So now we have to shade all the values that are both bigger than or equal to -1 and less than 3. The other way that you could represent this solution, so something to just make note of, is you could write it like this, but you'd have to include the and symbol. Or if you just want to write it as one inequality, you would have to say -1 is less than or equal to x, which is less than 3. And let's go ahead and graph these solutions. So if I'm graphing this set, should I have a closed circle or an open circle at -1? Closed, good. And if you were graphing all of those values, you would keep going to the right. But we can't just graph those values. We're graphing values that are also less than 3. Should you have an open circle or a closed circle at 3? Open, good, and then I would shade to the left. Now the question is, since this is an and situation, what numbers make both inequalities true? And the way that I like to look at it is, where did the red and the blue come together? And then guys, you know what colors red and blue make? Somebody say orange. What colors do red and blue make? Purple, good. So we would have this here to here. So you don't have to shade everything. You just have to really shade the answer, and an and situation should meet. How do I write this in interval notation? Should I have a bracket at -1 or a parentheses? Bracket, because it's a closed circle. And then should I have a bracket or a parentheses at 3? Parentheses, because it's an open circle. Parentheses means the number is not part of the solution set. Bracket means the number is part of the solution set. And that would be my answer. All right, let's try another one. Graph the solution of the compound inequality given below. Express your answer in interval notation. Sometimes I see confusion when we have multiple inequalities written as one. What I would suggest to you is if you're stuck, you could technically imagine taking away one side just for the moment. And then you would ask, well, what would be my first step? So if I take that away, what would you guys do first? Add the 4, nice. Now, since we have a compound inequality, the only thing I have to keep in mind now is whatever I add to the middle and the right side to keep the inequality balanced, I have to add it to the left. And -4 plus 4 is 0, so I'm left with 2x in the middle. Is less than or equal to, what's 12 plus 4? 16, good. Is greater than -6 plus 4 would give me -2. And then finally, what undoes multiplication? Division, so we're gonna divide both sides, or not both, all sides by 2. And we have x is less than or equal to 8 and greater than -1. So as I'm considering what values would make this inequality true, or really there's 2 inequalities here, where would I start in plotting values? -1, would I have an open circle or a closed circle? Open, good. And then where should the values go up to? 8, good. Should I have a closed circle or an open circle? Closed, nice. All right, turn to your partner, the person with the least amount of siblings. Share with your partner what the answer would be in interval notation. Mm-hmm. How many do you have, Jay?
So the first one would be -1, parentheses, and then 8.
All right, guys, go ahead and take a look. You should have parentheses -1, 8 with a bracket. All right, let's keep going. Example 4. Graph the solution of the compound inequality given below. Express your answer in interval notation. We've done 2. This third one might be a little bit more of a challenge. Let's think through it. Looking at the one on the left side, what would you guys do first? Nice, subtract 3x. And that would give me 1 is less than x. And for the one on the right, let's go ahead and subtract 2x, which would leave me with -x is less than -9. How do we get x by itself? Yeah, we're gonna have to flip the sign because we need to divide by a negative, and that will give us x is greater than +9. Okay, so I have to think about the answers that match the values of x that have to be greater than 1 and greater than 9. Jacob. Good question. When you divide by a negative, part of the rules with inequality symbols is you have to flip that sign. Jay.
You count it wrong, like if we, instead of just subtracting 2x, we add 9 and subtract x.
Nope, you would just have 9 is less than x, right? Yeah. Yep, same thing. So looking at solving now, here's a question, and you might want to think about this in terms of like a real life situation. I've got young kids at home. This would be kind of a silly question, but let's just, for this sake, try to figure out what our answers would be. If I said, hey, come to me if you're both older than 9 and older than 1. So let me say that again. If I talk to my kids and I was like, hey, come to me if you're older than 1 and older than 9. If my 2-year-old came to me, would that be correct? Claire, what do you say? Thank you. Claire's correct. The 2-year-old would be older than 1, yes, but they're not also older than 9. If I don't have a 10-year-old, he's getting there. But if my 10-year-old came to me, did he work? Is he older than 1? Is he older than 9? So did he meet both situations? Yes. So let's think about what types of numbers actually make both equations true. If this isn't quite making sense to you, you could just color in red and blue and see where do they overlap? Where do they touch? Where would the purple really be created? Because if we graph the numbers greater than 1, that would be everything this way. And if I graph the numbers greater than 9, that would be everything this way. Where would the purple match up with? Right after 9. Awesome. So our answer would be everything from 9 to infinity. I don't even need to label the red there because it doesn't fit the bill. It doesn't make both inequalities true. So only, in fact, I'll even write this, only numbers bigger than 9 are both greater than 1 and greater than 9. Okay, here's another question I have to ask you because it does come up. What if, so here's kind of a what if situation. What if you were given something like this? X has to be less than 1 and X has to be bigger than 9. So now what if I was in my house and I was like, hey, come over to me if you're smaller than 1 and bigger than 9. Is there any person who could fit both situations? No, there's nobody that can be smaller than 1 and bigger than 9 at the same time. So this one would be a case where there's actually no solution. If I said, hey, come to me if you're smaller than 1 or bigger than 9, I should have some kids coming to me, but not if I say and. Okay, now let's go ahead and transition to the or situations. So solving compound inequalities containing or finds all the values that make at least one of the inequalities true. All of you guys stood up at the beginning of class today because all of you were either a boy or a girl or had hair. You all stood up. In an or situation, you're just looking for everything that fits one or the other. It does not have to fit both. So let's go ahead and let's try example 4 together. Example 4, if we solve the one on the left, what would you guys do first? Subtract 9, good. And we would have 3x has to be less than -12. Then we would divide by 3. We would get x has to be less than -4, or on the other side, we would subtract 1 first, giving us -2x has to be less than 4. What would you do next? Divide by a negative. Tried to get you guys to answer that out loud to hopefully help you remind you, what do we have to do if we divide by a negative? Flip the inequality symbol. So we have or x has to be greater than -2. So now as I graph these solutions, I should have an open circle at -4 shading to the left and an open circle at -2 shaded to the right. We want to list everything that's shown there because everything makes one or the other true. So our answer in interval notation would look like parentheses, -infinity to -4, parentheses, union with, parentheses, -2 to infinity. And we box it. All right, last and final question. Graph the solutions of the compound inequality given below. Express your answer in interval notation. I would like you to turn with your partner on this one. This time the person with the most amount of siblings. You share how you'd solve, and then come together and discuss what would be the answers in interval notation. Go ahead and begin.
The other one is 6.
You guys, as you're graphing your answer, you want to think, what values make one or the other true? You have to list all of them. It's like you standing in the room, if you meet one condition or the other. Lydia? When do you use what? If all the solutions are shaded to the left. Okay, algebraically, you should get that x has to be greater than or equal to 1 or less than 6. If I said I want everybody to come to the front, who is greater than or equal to 1? So if you're 1 or older, come to the front. And if I said everyone who's smaller than 6, now this is a little hard to deal with because we don't have negative numbers, negative ages. But if I said if you're younger than 6 or you're bigger than 1 or equal to 1, who should be coming to the front? Everybody, exactly. So how do I represent everything as a solution? Negative infinity to infinity. Awesome. So if you were trying, I saw some people trying to kind of include 6 in their answer. Shaded wise, you might have had something that looked like this and something that looked like this. But the key is because every number works for one or the other inequality, we have to show that every number is a solution. So let's go ahead and let's write that. Every number works for one or the other inequality. If you were questioning, wait a minute, 6 has an open circle, you're correct in the fact that 6 doesn't work for this one, but it does work for this one. So I have to include it as a solution. It would be standing. Jay.
So, like, where is it that every question is?
Not every question, because if you look at the one previous to this one, the number -3 doesn't make one or the other true.
But so if they like cross.
If they overlap, yes, it will be negative infinity to infinity. Claire. You can just do the whole line. Yep. All right, guys, you have about 10 minutes to get started on tonight's homework.